Okay, so I'm just going to show you real quick how to run Autodock Vina really fast. So we'll make a folder and we're going to need all these files. Now the first file is from the Avogadro video. So basically you draw out the ligand and you're going to save it as a mol2 file. So you go ahead and put it in this folder we're going to work in. You will need this config file, which I will share with you. Basically we're going to fill this in throughout the tutorial. This is the receptor. So that's the structure file. I'll also give that to you. And Vina splitter from the Vina download from the website. Just basically take those two scripts and put them in here. So what we want to do first is load this HSA.pdb file. So we're going to go ahead and look for the file. Gonna go to File, Read Molecule. For me, it's already here, but you're probably gonna have to find it if you just started it. So HSA.pdb. It's gonna take a little while to load. Okay, after that, we're going to go ahead and merge all the polar hydrogens. So you see we have all the, merge all the non-polar hydrogens, sorry. We have all these hydrogens, but in order to run Vina, we only need polar hydrogens. So we're going to go to grid, macromolecule, choose, and we're going to go to HSA. Now you're going to see all these hydrogens diminish in a second. It's only going to retain the polar hydrogens. Okie doke, says all there. Non-polar hydrogens merged. Okay. Now it's going to ask us to save. You can save it wherever, but we want to put it back into this folder. So just for the time being, I'm going to put it in downloads. It's going to be right here, HSA.pdb-qt. I'm going to drag it and place it there. Okay, so the receptor is done. Now we're going to go ahead and open the ligand. So we're going to go find compound 1 mol2. So again, this folder is in my desktop. It's in a folder called Nicholas and Junaid. And it's in a folder called practice. So it's not going to show it here. We're going to have to go ahead because it's a mol2 file. We can show all files or just show mol2 files, and there it's going to pop up. Go ahead and open that file. This is just a general output of the characteristics of the ligand that Autodock tools notes for you. We're going to hit OK. Now basically what we do, we just want to save that as a PDB-QT. So as you can see the trend here, all we really want is to convert these structure files such as PDB or mol2 into a PDB-QT file. Right? So again, we're going to go ahead and save this as compound 1 PDB-QT. I put it in my downloads. I'm going to go ahead and drag it back in here. Okay. Now that is done. Now, so I'm going to change the representation of this this receptor. If you click the R1 in HSA, you'll then see the ribbons. Okay. Now, I believe if you choose color, I've never done this before. This is all geometries. I think if we do all geometries, it should stay. Yeah. Let's try one more time. If not, it's okay. Choose color. Maybe. No, I was hoping it would color by the ribbon. Well, I guess not. Oh, that's okay. So it's going to be a little hard to see. One, because this is not a good viewer. It's just to help you set up files for Autodock. So you could use this reference here. This is a reference, so if you could see, it's in the same pose here. Oh well, now it's in the same pose. Yeah. So you see these ribbons here, these helices here. See these two helices there. So these are the 6 domains I was talking about. IA, IB, 2A, 2B, etc. Now we want to make we want to be able to tell Vina, oh, you know what, we want to dock in this area. So we're going to have to set a grid box size. So if we go to grid box, you'll see that this grid now pops up. Now we can go ahead and play around with the size. But the first thing you want to do is always set this to 1, because this is Vina's default and you can't change it. So this is what it's always going to be, the spacing. So from there you can then go ahead and manipulate either the center of the grid box coordinates or the number of points in the XYZ direction. So when you do this, the box will shrink down. So you want to pick something that's, somewhat reasonable. So I don't know. I'm just finding out from the top of my head. Now let's try and just encompass IA. So it would be these ribbons here. So if I go ahead and move the center of the grid box, you gotta play around a little bit. See what's good. Yeah, okay. I go up a little bit. Now I want to encompass the whole thing such that Vina looks at the entire search space. So I'll go ahead. Perhaps we want to make the box a little bigger, at least in the red, so in the X direction, right? So I don't know, we could put a little higher, 25, maybe even a little more, 30. Maybe a little more, 40. And then we can move it a little more in the X direction such that it covers everything. Okay. Now it looks like the bottom is still open as well, so might as well adjust the blue a little bit. Okay, see, now we're getting somewhere. So that is somewhat reasonable. We have about everything. We could expand in the other direction as well. If we go a little down, if we really want to get everything, that's okay. This loop doesn't really matter. Most likely not going to contribute to the binding. And that's pretty good. We can classify that as docking to at IA. So again, now what we want to do is open this config file. So you're going to open it in a text editor. My .tx extension by default opens in text editor, so do that. So we can start filling this out. Now you got to keep this open because you want to record these numbers. So these numbers will basically be placed here. These number of x points in the x, y, and z dimension will be the size. So we go ahead, we space only one space apart, and then we'll just put the numbers in. 30, and then the center will be these coordinates here, not these. This will be the coordinates. So negative 1.169, 27.693, and negative 15.676. Okay, that's good. Now we can go ahead and fill out the receptor and the ligand are the two PDB-QT files. They will always be the PDB-QT files. So the receptor in this case is HSA PDB-QT, that one, and the ligand is compound 1 PDB-QT. Now the out file is whatever you want the output to be named. I will just combine the name of the two molecules. But I will also put the domain just so that we know that we're working with this, so we don't get confused. So this is IA. So I'll put IA there. And you just got a same extension, PDB-QT. Number of modes is how many outputs you want. So how many predictions, or how many predicting docking poses you want to output. It's always good to set it to 20. And there's also one more parameter that's not here. Exhaustive. Actually, no. Let's not do the exhaust now. We could keep it at number of modes 20. Okay, so that's it. We're going to go ahead and save this config file. That's saved now. We can go ahead and close it. We filled out everything we need. And that's about it. And now what you want to do is go ahead and open your terminal. We should go to the working directory. You can type it out if you want, but an easy way to do it if you have the folder right in front of you is to just drag. You're going to do CD, you're going to hit one space, and you're going to drag. And then you go into that folder really fast. So in order to call the Vina script, perhaps for you guys, since it's your first time, you're going to have to give your Mac OS permission. So it's always good to do the chmod +x Vina. That will automatically give you permission if you're having trouble with the next step. So then what to do is then this is the command to launch Vina. So again, this is a bash script, so you could just do a period and a / and do that, and then we're gonna say that we're gonna call the config parameter, and then we're gonna call the config text file, and that's about it. You're gonna hit enter. You're gonna see right here that it's calculating. Here we get a little time slot. And we just wait from then. Since these are small, they won't, since the leggings are small, it won't take that long. Okay, so the output finished. Here we can see the binding affinity. This RMSD is kind of a pointless RMSD. It tells us how different one structure is from another. So basically what the RMSDs after the first one are telling you is that the difference between these against the first predicted docking. That is kind of useless at this point, so we don't really have to worry about that. But basically, so yeah, these are the binding affinities. Now, you could save these, you don't have to. One, because all these results will be in the output file. So, as you see, this file got generated right now. If we go ahead and open that file in the text editor, we'll see, I give it a sec. We'll see here that for model 1, the binding affinity is recorded right here. So it's the same thing. And if you go ahead and look for model 2, it'll be right there. 8.0, same thing as as here and so on. Okay, so you'll notice that this one PDB-QT file has all of the coordinates for the predicted binding poses. But what we can do is go ahead and split this PDB-QT, because we only care about the first one. So to do that, we're going to use the Vina split script. So if we do Vina split, okay, so you see that right there means we have to do chmod plus x to allow for permission. So now we have permission. Now, depending on your Mac, you do or do not have to do that. It's up to you. So we do Vina split, and then we're going to do the input parameter, and we're going to put the input as the file that was generated from the first Vina script. So the HSA compound 1, if you hit tab, it'll come up. And then you just hit enter. Ooh, oh, sorry. I forgot the AIM Vina splits. Okay, now you'll see here all these files got generated. So that's good. So that's all the individual ones that were all jumbled up in this file. So what's important is the first one, of course, the one with the lowest binding affinity. If we go ahead and load that one back into Autodock Tools, so I'm going to get rid of this grid box. You can click File, Close Saving Current, and you'll see right here the predicted binding site at that location. Right now, if you wanted to look at all of the binding poses predicted, what you could do, so I'm going to go ahead and delete this one. What we just uploaded. We're going to load the first one. And to do that, we can go to Analyze, we can go to Docking, so we can open Autodock Vina results and load the first one that we got, the one that has all of them in the file. And to look at all the poses, we could just hit the left and right on your keyboard. So there you can see it also shows the binding affinity. So you can see that all the poses are generally the same in that one area. Right? That's a good way to just look at all the results fast. Again, the best one is the first one. So now that we have the PDB-QT of the best one, I'm going to go ahead and delete this. I'm going to load the first one again. And because PDB-QT is only good for Autodock, we want to convert it back into a PDB. To do that, we're just going to make sure that we hit the active button. So this will activate. Any other command you do will only be concentrated on the ligand. So if we do that, and go to save, and then write PDB, we'll write the PDB for that one PDB-QT of the best one. So again, we choose somewhere we want to save it. It already wrote the name for us. Again, I'm going to put it in our downloads. And because I don't like this name of ligand 01, I'm just going to put HSC compound 1A best pose. I mean, you can put whatever you want, but I just leave it that. Leave everything the way it is. Gonna hit OK. I'm gonna go ahead and drag it back in here. And so yeah, that's about it. So you're gonna go ahead and record that. Once you save this, that's good. Everything is good for now. So you're going to repeat that again 5 times in each domain, and for all the domains. Now, let me see something. So one thing we want to do But you know what? No, I'm gonna leave it like that for now. Just let's do all these dockings, and I'll resume and make another video about how to continue. Okay, let's see.